Thanks. Okay. Thanks everybody for sticking around a few more minutes. I'm going to spend a couple of minutes talking about technology. The technology that's available. I just heard from Nick at the AG's office. They're actually looking very closely at this technology. They got a grant, so they're actually in active evaluation. It's pretty exciting, and I'm really anxious to talk about this because it's such a part of the solution that I'm recommending. By the way, just put them over here. I've got pamphlets about our foundation and my business cards. Please, at the very least, take one of my business cards and go on our website and see what we're doing, and send me a note if you could. Send me a note of support. Tell us what you think, and you know, the more support I can get from you guys who do this great work all the time trying to help us. And I was remiss in thanking the organization, not thanking each and every person here, because you really are at the front end of this thing, right? I mean, you know, look, I'm doing what I'm doing, trying to get some people to think a different way and get some laws passed. You guys are down in the dirt with this thing every day, dealing with this stuff, and it's got to be really, it's got to take it out of you. So God bless you, and thank you so much for what you do. So anyway, if you would take a pamphlet, take a card, check out our website. For those of you who are Christian or Catholic and would like to hear the incredible story around the miracles happening and all the spiritual side of it, please send me an email. There's some of that on the website too, but I can tell you a story that will convert you or give you great hope and give you great faith. So God is giving us tremendous consolation and compensation for this. So let's talk about some technology for a minute. A little easier to talk about than the horrible stuff we talked about a few minutes ago, because this is interesting and exciting, right? So as we talk about the technology for detecting fentanyl, some very specific issues come to mind, right? First problem we're dealing with is its vast availability, right? This availability of this stuff is going to become unprecedented in history of drugs. Maybe, you know, marijuana, the kids are growing in their basements, but this is really going to have availability that's unprecedented. It's everywhere. Right? So the testing has to be immediate, it has to be available, it has to be reliable, it has to be defensible, because this stuff is going to be everywhere. Second thing to consider is its intense, uncontrollable strength. So we talked about the problem of mixing it and how it's deadly. It's deadly because nobody can control the intense strength of it. And yes, that's a fact. And that's something else we have to consider, because when it comes to testing it, of course, the street cut levels of this stuff are extremely low concentration. And that gives us some challenges, those of us in the world of scientific instruments. Okay? So, if you want to be able to catch this stuff at the street level, at the street, and not have to go off to the lab, that really creates some challenges. And the most important thing is the incredibly numerous and expanding list of available analogs. We talked a bit in the last talk about the importance of analogs and why we make synthetic chemistry to begin with, and then why we make analogs of that. Well, this is no different. It's a business, and it's a business making a lot of money, and analogs is the path to big time bucks. So we got to be considering that. I'd like to give this, I'll put this logo up here. This is 908 Devices. This is the company that has the one technology that I'm going to talk about here that really fits in. I'll talk about the other technologies. I developed one of those technologies at one point in my career, so I know a lot about it. But this is the one that really impacts the fentanyl, so this is the one I'm really going to focus on. And again, here in Ohio, the AG is buying this through a grant, and anybody who has some grant money or is after it, this 908 Devices. It's not the only instrument that you need in the arsenal. You need others too, because this is kind of expensive, and there are other ways you can deploy less expensive things in a total strategy. Okay, so I'll talk about that. In the unprecedented availability of fentanyl. So here's the stuff off the dark web, right? And I work with these guys at Fed Resources. They got the licensing. They can go buy this stuff and go on the web and do this stuff without, like, the government showing up at their house. So they give me this stuff to show. And this is where they play around on the dark web, and they start playing around with these orders. And you look at this stuff, it's kind of fine print to see here, but you see, you know, this ad, hey, look at this, 95% pure carfentanil, 50 grams, roughly 50,000 doses, wonderful. And look at this, just $6 grand, how's that, huh? For 50,000 doses, free shipping worldwide. It's just like ordering on Amazon, right? View our offer, hit this button here, view our offer. It's just like ordering on Amazon.com. And I'll show you how much it's like that. And then these next couple of things. Look at the sellers. Look at their names. I got Fent, Oxygood, right? Treasured Stamp, 10 USA. These names, right? Every one of these people delivering through the Postal Service for you, making life easy for you, right? And of course, I guess most of you guys don't take it to their own mailbox just in case. They do it to somebody else's mailbox. But look at this stuff. And then you go down here, look at the comments you'll see when these guys go on chatting with these guys, right? Look at this. Any tracking information, free priority mail, tracking and reship guarantee. Reship guarantee means pay a few bucks extra, and I'll guarantee that shipment. DEA gets it, I'll send you another batch. What the heck, right? Look at this guy. Came today, 6 p.m. effing mailman, always late, right? But this guy is my new best friend. Look at this stuff. Wish I ordered more at this ridiculously low price, right? Express mail. You see all these comments, right? It's just like buying anything else on Amazon. What's a good one here? Oh yeah, arrived perfectly before holiday. Wow, vendor is perfect. Isn't he great? It's crazy. This is how this stuff, you want to talk about availability. This is drugs we're talking about. This is drugs that are lethal. These are drugs that killed 30,000 people last year. Strength and toxicity. Here are the 3 jars again. You can see the heroin jar a little better in this slide. Okay, so if you look at these estimated lethal doses, aspirin, you have to take 35,000 milligrams to actually get yourself into trouble medically. Heroin's about 30 milligrams, fentanyl 2, and carfentanil 0.02 milligrams. So you're down into the microgram level, which will be lethal at microgram. I can assure you, there is no drug dealer in America capable of reliably mixing microgram level powders. So I can tell you the results, right? Lethal dose of fentanyl is about 2 milligrams. That's 2,000 micrograms. The HP mass spec we're going to talk about in a minute has a detection limit around 20 nanograms. And that's really, really important. You've got to have a really, really, really low detection limit for reasons that have to do with your safety. So that's about a 1/100,000th of a lethal dose, or really less than 1/1000th of any dose that could even make you feel or give you any sort of reaction at all. So we're way, way below the levels that you'd have to worry about, right? So the detection technology, this is sort of a purity scale right here, okay? So we go from here, this is 100% bulk, this is a full brick of heroin or fentanyl with nothing else in it, and this is basically just pure cutting agent over here with nothing in it, right? Along that scale, opioids in transit are here at that, sort of 100% level or very high percent level, and heroin on the street gets down to that sort of percent level, maybe a little less than a percent, hundreds of parts per million, okay? And that's all good with Raman, FTIR, colorimetric techniques, the strips that you know about. This is Raman is a product I used to work in called TruNarc. I worked for Thermo Fisher, the TruNarc. Many of you may know that product. I was part of that team at Thermo. So these are great. And FTIR, I developed the FTIR for Thermo, and all that works fine. When you get to fentanyl, though, on the street level, you start pushing the scale down into that milligram, microgram sort of level. And you want to get that into grams of cutting agent. So you're talking about percentages of 0.01%, 0.001%, single parts per million. So that's where you start needing mass spectrometry as a technique. Now this is mass spectrometry. You usually hear it referred to as GCMS, LCMS, HPLC. You see all these different terms. MS itself is what we're going to talk about here. And then you get into the super lab technique where you put a GC or an LC in front of it and you get a full laboratory test. But anything you're going to see fentanyl in the street down to levels that no one would bother mixing because they're just, we're talking about levels where you're going to find what fell off the sides. So we're going to cover everything that you're going to see in the streets. So then the final problem I was talking about was the power of analogs. So this is pretty interesting. Here are the analogs reported by DEA since 2016 to 2018. So we started with, your basic fentanyls here, which all came in really in the market in 13. By 16, you had about 4 or 5 analogs in the space. Now you're up near about 20 analogs. Remember, we have about 500 analogs calculated that can do the same work as the fentanyl and carfentanil that you know of today. So this 20 has a lot of headroom. They got 480 to go. And thanks to the girl at the Washington Post and the lack of our passing of SITSA, they can play whack-a-mole, unfortunately. Okay, so this power of analogs is a big deal, but let's talk about why. Ooh, wow, that's pretty scary stuff, right? Okay, so this is actually pretty simple, and what I'm trying our CID data. We'll talk about what CID is in a moment. And, but this is a regular mass spec that doesn't use that process. And you see, when we start bringing in the CID, you start seeing we pull up these signals and we start getting this extra information. Why is that important? These are different fractions of the full molecule that we're looking at. Okay, so this is the molecule of fentanyl here, and all these things out here are the functional groups that make it carfentanil, remifentanil, actylfentanyl, acetylfentanyl, all these different types of fentanyls. Okay, what happens in your standard technique, like your TrueNarc or your FTIR device, is every one of these has to be calculated to the spectrum that it responds to. That spectrum has to then be loaded into a library. So as new analogs come along, those analogs have to be found in the field, sent to the lab, characterized, sent to the vendor. They have to make up a calibration for it and then put it into their library. The first big advantage of mass spec is we don't need that. By looking at the base molecule, so what mass spec does is it takes this thing and it ionizes and it makes heavier molecules out of these things, and then it bombards them so they fall apart. And you look at all the different fractions of the molecule, and then you look at their mass. So you're not looking at a full wave profile of light that interacts in all the microphone doing something funny? It's not all the light reacting and then creating a spectrum. You're actually measuring each and every molecule. So the ability to measure those molecules is intrinsic in the instrument. And that's what this is all saying, is that all of these different analogs, instead of building a library over years, one at a time, they're all in there already. If any of these molecules are in there, this instrument's going to find it. That's the advantage of mass spec. Mass spec fits into what we call the golden triangle here of the three big techniques for molecular analysis: NMR, nuclear magnetic resonance vibrational spectroscopy, FTIR and Raman, and mass spectrometry, right? And these three together make up the full universe of molecular testing, okay? What we really need for fentanyl is to get at this mass spec. And until now, that's only been a lab instrument, right? Sensitivity, the ability to get to the low cut levels. Mass spec has this big advantage of being able to look at molecule at a time, so its selectivity is very, very high resolution, right? So you look here, a gram of material is about a sugar cube. A sugar cube weighs about a gram. And if you're looking for a gram type of, a bulks of a gram or so, you've got FTIR here, and this is long wavelength Raman. This is your short wavelength Raman here. And so that's about where your dosages are for heroin, right? So you're going to see that pretty well. You'll see all of that. When you start getting this kind of a heroin into this kind of a bulk, so this is your cutting agent, your heroin, you get this kind of a ratio. You'll see that. That's about a 1% ratio. You'll see that pretty well. When you start getting into fentanyl, you start to talk about a fine grain of salt now. So this is a sugar cube, this is a coarse grain of salt, this is a 1/1000th, that fine grain of salt. You've left all these behind. You can't see this stuff anymore. And when you start talking carfentanil, if you have enough carfentanil to see with these instruments, everyone's dead. Right? No one's looking for them. So, you've got to have mass spec to get to this level of sensitivity. That's what's so exciting about this, right? Because a lot of these moratoria went out for testing this stuff in the field because there was no good reliable way to do it other than taking some chemical tests and mixing them, and then people are going to get sick. We've got to find a passive way to do this test, a safe way. So you put this type of instrument that looks like one of these. It's about the same size and complexity to use, but it's 1,000,000 times more sensitive. Right? So forget about just looking at the small grain of salt and then the small grain of salt and then another few smaller grains. You're down to the nanogram level. Why is that important? That's important because if I take a bag of drugs and I want to see if there's fentanyl in it, I do not want to open that bag, right? That's what's dangerous. So if I want to check it with Raman, the big advertisement for Raman is I can shoot through that bag and I can see what's inside without ever opening the bag. Well, guess what? We can do with mass spec too. Why? Because we swab and then we put it in the instrument. You're only going to swab the outside of that bag. If there's a bag and it's got fentanyl in it, any amount of fentanyl in it, unless it was packaged by a pharma company in a clean room, there was a ton of fentanyl on the outside of that bag relative to a mass spec. Not a ton relative to your safety, but to a mass spec. If you're wearing rubber gloves and a P100 mask, you're completely protected. And yet you're going to have enough fentanyl in that bag, swabbing it. Not only will you have enough for this instrument to see it, you'll have to create several generations of swabs so you don't oversaturate the instrument to clean it. Okay, that's how sensitive it is. So that's what's so exciting about finally getting this mass spec out there. It's a SWIG drug category A technique. It's the gold standard for these drugs. It's ubiquitously taught all through the industry and recognized. But the problem is it takes PhDs, lab coats, lab conditions, right? It's very expensive to own and operate, very complex, very large, very expensive. Until last year, when finally was introduced in a portable version, right? So it finally got field portableized in 2017. That field portable version has a few things like it's 4 kilograms, very easy to carry around. It's got a hot swap battery, it runs all night on a battery, right? And it's got chemometrics. So the most important thing, and I've been doing portable instruments for a good part of my life. In fact, that's how I actually make my living, is doing portable instruments for consumer product testing. And portable instruments, people think of portable, they think, well, easy to carry on a battery, and it's small, and it's light. It's all those things, yes. But I mean, even if it had to be fairly large, you wouldn't mind carrying a police car. The real key to portables in the modern world is what we call chemometrics. And that is the ability to put the scientist in the box, right? So whatever that scientist process is, we can codify that, put it in algorithms, and so you just put the sample and it gives you an answer. And you don't have to know anything about the science. And that's what we've done here. When you do that with FTIR, it takes a lot more work to build the knowledge into the instrument. This one, the instrument knowledge is instantaneous. So that's a big advantage. Okay? That's chemometrics. That's the ability of the instrument to do its own thinking. So finally, we have field portable mass spectrometry. I put this in as kind of a joke. I say field portable mass spectrometry. You see this giant building at Oak Ridge National Laboratory. This is the first mass spec, the Calitron, 1943. We all study this stuff, right? So I want to show it. It's all exciting for me. I go to Oak Ridge all the time, and I get to see these big, crazy the cyclotrons and all this stuff. So that's what the mass spec used to look like. So the little thing I'm about to show you started as this guy here. Okay? So you've got this technology you can have in your car for $65,000. This thing costs a lot more than that. So that's the old one, 1943. The original mass spec was developed so that they could separate different isotopes for the Manhattan Project to make in the bomb, right? And they discovered a lot of things about how they can use this fracturing of ions and measuring their mass to do chemical analysis. Pretty fun stuff. Okay, so here it is. This is what the thing looks like. This is the actual mass spectrometer. It looks a lot like one of these FTIRs or one of these Ramans or these other little portables. It's all on a battery. It's got its little chamber here for testing. So you got to wear rubber gloves here. It's got the big buttons so you can wear the rubber gloves. It's in this drug hunter mode. There's a chemical warfare mode, and there's an explosives mode. We're worried about the drug hunter mode, okay? And here it is. It's a real mass spec. See, if you look at these kind of specifications, you look at these, and these are the typical things you'd see for a laboratory mass spectrometer. So it's the real thing. It's the real McCoy, a real mass spectrometer. And here's the technology of mass spec, and it actually follows these principles, right? We take an electron beam, we ionize a bunch of the molecules, we then bombard them into each other so they fall apart, and then we individually, we push them through a magnet, and we get them to fall into certain places based on mass, and then we distinguish them, we chemically analyze them. That's what a mass spectrometer does, and that's what this little guy does. So it's an honest-to-goodness true mass spectrometer. So what about strength and toxicity in this cut, right? This is what you're hopeless to see with any of those optical techniques or vibrational techniques. You're talking about 100 nanograms of fentanyl and a diluent of 10,000 nanograms. It's a 1 to 100 ratio. You won't see that, right? You won't see those cuts at 1 to 100. We see it very easily. Not only do we see it with this instrument, but when you dose the swab, you have to, as I said before, create 2 extra generations of the swab. If you were to take a 100 to 1 dose of material and swab the bag, and just get what you got for that, and then put it in the instrument, you would get a positive result, but then you would have to spend 5 minutes decontaminating the instrument because you'd oversaturate it. So what we always teach to do is to make multiple generations of the swab and then keep moving down until you actually see the drug. Because the initial swabbing would be too much for the instrument. I mean, not that it'll damage anything, but you'll have to clean it. Okay? So, talking about those analogs, now we can see all the different analogs. We've got 12 fentanyl analogs that have been the most seized, right? I think there are a total of about 18 or 20. 10 are the most common, right? So we're insensitive to the different functional forms of these chemicals, right? Which is what something like FTIR is sensitive to. So we're seeing through all of that. We don't care what form it takes, what functional group it takes. we're looking at the base molecule. So we have all of those things in there for all of these different illicit drugs: heroin, cocaine, meth, other synthetic opioids, the U series, and all those different things. About 87 identifiable drugs right now. And actually, those new ones will just come by nature. We won't even have to change the software. As the new analogs come out, they'll just be detected. And in this reach back service, we'll actually put reporting and things like that. But they'll be detected by the instrument, right? So we can classify all these fentanyl analogs. I've heard estimates between 1,900 and 3,000 total fentanyl analogs available when synthetic chemists do the math and they figure out how many we can do. And we do not do a library or a target list. This is what's really important. In the mass spec classifier mode, you're not going into a library. You're actually measuring the mass of the molecule and understanding what that molecule is. That's a very, very different way of operating. Very different. It means you'll catch all of the analogs in real time as you see them, right? The chance of alerting to any one of the 2,000 analogs right now is 70%. And that's going to get better as more analogs come out. Right now it's 70%. If you took any one of those 2,000 calculated out there, the vast 90+% has never been made. Once they're made, you put it in, you would have a 70% chance of hitting them with a false positive chance of less than 3%. So this is just orders of magnitude better than anything you've seen out there so far. One of the questions I do sometimes get is, what about the colorimetric tests, right? They're doing a similar chemical process in a sense. Why aren't they seeing this? And the only answer is, we don't really know, but they're not. We just know that they're not. They're getting a lot of false positives, and it might have to do with the way that the chemical reaction is taking place. You've got to be very careful how you do it. You've got to do it in a closed chamber because you can't let the liquids escape. So what we're seeing is even the people who use the strip tests, they don't use that as a confirming test. They'll only use that just to get some sense of things, and then they'll use something like this to get an actual confirmation test. So the instrument uses a process called collision-induced dissociation. I misspelled this as collusion. I wrote the slide the other day. So one of our brain is collusion, but anyway, I wrote it. It's collision-induced dissociation. What that means is, once we ionize the particles, we keep banging them into each other so they fall apart, right? And it's collision-induced. That's what creates the separation. And that's what gives us a chance to look at the individual molecules, right? So we ionize the fentanyl molecule, hit it with a bunch of energy to reionize it, and then ultimately get it to fall apart. Repeat this process until it completely dismembers, right? And then once we do that, we can push it through a magnet, and we can sort things by mass. Okay, so that's some of the theory and how it works. So this is what it actually looks like. This is operating the instrument. You pull the chamber open here. You drop the swab strip in that you swabbed. You put it into this drug hunter mode. And then you just hit the button and off you go. And that's it. And it goes through a process all by itself. So a little video, and you'll see this is a real test being done at one of the ports. And we got a positive hit for fentanyl. Starting analysis. First thing it's doing is heating up. And it's going to evaporate the sample, volatilize, and turn it into a gas. Right, so we can get those molecules moving around and get them ionized. So it's heating, vaporizing the sample. So it's creating the vapor, it's ionizing, it's creating the bombardments, and it's capturing those mass energies, cooling down, cooling down, cooling down. Process is done, it then takes the data it saw and it does an analysis, it sees what mass numbers it got, and it gives you the answer and alarms for fentanyl. That's it. That's how it operates. That's the test. And the only thing that makes it more complicated than that is what he did there was swab and then right into the instrument. More than likely, that didn't look all that saturated. That must have just been trace levels that hit somewhere. But if you did that on a real bag of drugs and dropped it right in, you would see the thing saturate the full peak. It would give you an instant alarm. And then you would have to go through this empty heating cycle to clean the instrument. It takes about 5 minutes. So the only thing I would say from that is is again creating multi-generations and swabs. So then you can put these reports and all the data's there, and this is what I mean about any fentanyl analog is out there. It'll hit for a suspected fentanyl analog, and then ultimately through reachback service, you would get all this data filled into the software that could create the right report. Okay? And that's what we're talking about, reachback service. So one of the things that the company offers, is when you're out in the field and you get a hit, bring that data in. And 24 hours a day, one of the scientists from the company will get on, look at the data, send them the spectrum, the spectrograph, they'll look at it, and they'll confirm your results. Usually what's been happening is it comes also with a colorimetric test result as well as a Raman test result. And it's dramatic. I mean, we've seen numbers where it's, you know, in a month I've seen reports, there was 20, 25 samples that came through, reported as fentanyl, and only one of them was. And you know, Raman hit on 24 of them, and colorimetric tested on 18 of them, and mass spec only hit on one that was real. So it's a complete different test. You can't be doing fentanyl street level testing with really anything but this device. As I said before, it has its place. You know, you can buy 3 Raman instruments for one of these in terms of the cost of these things. And if you're at a port and you're looking at pure stuff, and what you're trying to do is confirm that that break is or isn't drugs, that's great. That'll work just fine. With one caveat, we had one where, since Raman is sensitive to sucrose, it was packed in sugar, so in oversaturated you couldn't see the fentanyl inside. But generally speaking, if they're shipping it in the ports, you're going to find it that way. It's when you get to street cup level you really need this. So that mix and match of using the strips or the Raman FTIR techniques as a way to do a quick first order test and then confirm it with a mass spec. You know, mix and match of having fewer of these instruments. So that's generally the way that we see people using these. It's been pretty popular so far in the field trial. We did these several field trials, and we saw all these things where compared against the Raman and FTIR, we were able to detect these trace level threats where we found like half of a certain number of these things had fentanyl, where the FTIR and Raman didn't see it at all, right? Less than pure material threats, counterfeit pills, right? Diluted things into street mixtures or even into shipping mixtures. I said the sugar experience that we had. And again, no training experience. We've gone on these field trials and just put them in, and you know, I mean, literally 15 minutes training and off and running, there they go. There's lots to learn over time, but you can get up and running on this thing in no time, right? And again, demonstrating this ability because of trace levels to promote officer safety. And I'll repeat it again. We saw on the video with the gloves, you didn't see his mask. P100 mask, rubber gloves, all you need to be protected is fentanyl. And with that, you're going to get more than enough on the outside of any packaging. If there's fentanyl on the inside, on a 20 nanogram detection limit, there's going to be more than enough on the outside that when you swab it, you're going to find it. And you're going to find it at 20 nanograms, which is thousands of times below. Give you any effect whatsoever. So keeping everybody safe is a big part of that. Okay? Right now, there's been one delivered now to every state in the United States, so everybody's got one. There are hundreds now delivered worldwide. So as these labels go up, you can see the different agencies that have bought them and deployed them. So it's out there and it's working. And as I said, all 2,000 calculated. We've only seen 18 or so in the field, but all 2,000 are already detectable. And the more of those that come in and get programmed in, that'll even get better and better and better. So the tool is here, it's available to you, and the Actus Foundation is really, really pushing on this because we have to be able to take the street. I go and I talk to my Nassau County DA, and she says it takes 6, 7 months for her to get a lab test back. But she's got a moratorium. She won't let the police test in the field because it's dangerous. And so we wait 6, 7 months for a lab test. The other thing to mention is this is a sweet drug class A test. So is it defensible? We say it is. It's certainly defensible to get a plea out or something like that while you're waiting on a lab test. If this thing said you got heroin, you got heroin. And that lab test is coming back positive. Now you're still going to have a lab test for full defense in court, I suppose. The lawyers will tell you. But anyway, this is going to be an absolutely accurate test in the field. So it should give people the comfort to know that the officers are safe and to know that they're getting good, reliable testing. Okay? And with that, mass spec is now available in a handheld, easy-to-use form factor. For fentanyl, it overcomes many of the challenges, right, with other technologies because of the million-time sensitivity, because of the ability to see the analogs. right? It's being tested by multiple federal agencies as we talk, as we speak. This is what we call high-pressure mass spec. It's a special kind of mass spec. It's distinct from what you hear of GCMS or LCMS in the lab techniques, right? It gets all the fentanyl variants, and the company is very aggressively adding to cannabinoids and different other kinds of drugs for synthetic marijuana and everything else. So, okay? Thank you. If anybody had a question or anything, either on the last discussion or in this, I'd be happy. A couple of people asked me questions outside. Anybody have any questions, comments? No? Okay. Well, again, oh, I see a question here.
How does this, the product, does this work with mixtures? So if you have something in your bag, and let's say it has carfentanil, and it has cocaine and methamphetamine all in the same bag, will it identify all three separately?
Absolutely, yes.
So you have three things come up?
Yes, it will. Absolutely. That's one of the fundamental functions of the engine, yes. Was there another question? Heck? Facing somebody else? No? Last chance? No? Okay, great. So again, I left the pamphlets here. If you grab one, please take my business card and take a look at our website. And if it means anything to you, I'd love to get a note and know that you support us. Thank you very much.